Hi everyone. Sorry about like this issue of microphone we're having. So Jeremy solved this. Sahiti, thank you for inviting me here. I have never been to any other workshops of bioinformatics or biomedical informatics club. So all of you are from IU only, or is there anyone from non-IU? Okay, so yeah, is that all? Okay, so I'm also just like a student, like you. So I am actually from like the Purdue program. So I am doing my PhD in electrical and computer engineering. So soon the department is going to be like Purdue University-Indianapolis, like due to the split. So IU and Purdue will be like separated. So I will be transferring to the biohealth informatics department. Like I will be transferring my PhD to here. So currently I'm a third year PhD student at ECE department. So, okay. So how many of you like are familiar with MATLAB? Is there anyone? No. Okay, a little bit. Yeah, even like I'm also familiar a little bit. So usually like in engineering, it is pretty much especially in like electrical or computer engineering, or maybe like electrical engineering students, they are more familiar with MATLAB because we tend to do a lot of signal processing thing and everything. Even like when you do some stuff with digital images and all, then we use MATLAB, and MATLAB is basically like founded by MathWorks. So it's basically like math then lab. So you need to do a lot of computation here. So we will not go into details in this. So I will just give you some basics of how to use MATLAB, especially if you want to do digital image processing. So there's very basics of using signals, like you do some, you get some signal equations and then you do some computation with that. We will not go into details with that. And though I have written that image processing will be done by MATLAB and Python, but today I guess we don't have much time to cover Python, so you'll only cover MATLAB. So you guys are like more familiar with Python, right? So all of this thing that we do MATLAB, some stuff can be done in Python as well, but today we are just going through MATLAB because in MATLAB it is vast, more functions, more libraries are there in MATLAB than Python. Okay, let's move forward with the workshop then. So, okay, I gave my brief introduction. I did my bachelor's from Bangladesh University of Engineering Technology in electrical engineering. And currently I'm doing research mostly on optimizing machine learning algorithm, focusing on improving healthcare. So this is why I'm doing my research in health informatics department. So I am currently a third year PhD student at Purdue School of Engineering and Technology here at Indianapolis. So today what we will do is like basically I will give a brief of what is image processing and why it is important in informatics, not specifically in health informatics. Informatics is a vast area, so we will not just keep our focus on health informatics and what is the benefit of doing that and what exactly we do in image processing. So, okay, so I want to ask at least one person from you, like what do you understand from this phase, digital image? Anyone? Saiti, you start. What's exactly digital images?
I would say just a visual representation of something.
Something recorded or captured.
Yeah, traditional piece.
So does anyone know like how initial, like the first, very first image was captured? Yeah, the very first image. Do you know? So the theory of reflection that was first used to capture an image, and then like you reflect the image on a reflect the light from the image on a piece of paper, like the photographic paper, and then you get the image. So right now, that one is not a digital image. That was basically like on a paper printed image. But now the images that we deal with, those are digital images. We can capture them on our digital mobile, like our Android phone, or we can do it on our digital camera. So basically what we think as like a mere representation or mere representation of our a scenery or maybe a person or anything that we want to represent, that can be like recorded in your digital devices. So, but technically, as an informatician or maybe just maybe as an engineer, as a professional, you should understand how this images are recorded or maybe stored in your digital devices. So they're basically stored as the representation or the arrays of pixel values. So I wanted to show one thing here. In order to do that, maybe I can show it later words, that how you can see the pixel information from an image. So right now, the thing that you are seeing, this is a projection coming from the projector. But if you consider this as an image, is it only coming as light? It's not coming as light, but it's giving you enough information that you are visually seeing by your eyes as a representation of light. But there's many information. Also, there's values, or there's digit information, or any type of digital information that is coming. But by your eyes, you are understanding as a light. But this is not exactly light that you are seeing from the projector. So also there another information you need to remember, that there's common color spaces. There's basically 3 color spaces, red, green, and blue, that we call it as RGB. So anything other than that will not give you a colorful representation of image. You must have these 3 color spaces, red, green, and blue. One missing, and then you will not get a good quality image. You will not be able to get the information out of it exactly the way you want. For example, even if I capture an image of a tree, which is green, there will be red and blue color spaces as well. It's not only just like a green thing. There will have at least 3 color spaces. Sometimes in many like different type of images, I have seen more than RGB spaces. Like there will be maybe, I have dealt with images where we had like 10 color spaces. That's very like highly unlikely, but there are images for that as well. So yeah, so understanding this color representation is very fundamental if you want to do accurate image processing. So also image resolution, the more qualityful image will have high resolution. For example, we use YouTube every time, right? So we maybe like when you are playing a video on YouTube, there is an option to change the quality of your video. Sometimes it's like 144p or maybe like 1080p. Which one is like highly qualityful video? 1080p, right? So the more qualityful image there is, the resolution will be higher. Also, the image format, you should know what type of images we have seen till now. JPG, right? And PNG, these two are mostly common. There is also this TIFF or TIFF images. In this type of images, I have seen more color spaces than RGB. And DICOM image is mostly the images that we use in bioinformatics or in medical images. Those are considered as DICOM images. So yeah, so you need to understand these formats as well. Does anyone know any other format for images that you have seen? Yeah.
Yeah, there's like WebP.
Yes, WebP.
AVIF.
AVIF. Oh, okay.
Yeah.
But also some people say that GIF, that is also image. That's not an image. That's basically like an animation or something like this. That's not image. So maybe, yeah, someone is saying something. Yeah, SVG can be also considered as image. Yep, right. Okay, so yeah, when I was saying highly like high resolution image, this is what I meant. You can see these 2 images. Basically, this is the representation of one same thing, but the first image, like the image on the left, this is showing 3000 DPI. So what's DPI? Does anyone know what's DPI? DPI means this is actually like when I was very small, like I was, yeah, someone was saying something. So when I was very little, someone is saying something from Zoom maybe? Yeah, so I used to go to like the photo, I don't know, like the photo studio where they used to click photos of us and then they used to print those photos. Like maybe I was 5 or 6 at that time. So maybe you guys also visited the photo studio, right? Yeah.
Is it different from, yeah?
Yes, it's different. Yes. yeah, you said a very good thing. Like PPI is a different thing that is more needed for us when we are doing image processing. But this thing was when I saw this when I was very little. So they used to print the photos. So this is basically dots per inch. So when you are printing a photo, the photo paper that you will be using to print your photo, you need to determine what will be the quality, how many dots per inch of your photo paper will be taking to represent this image. So definitely 300 dots per image, that will be very high quality image, and 72 will not be. So you can see like this kind of like blurred thing, this is not. And then there's also another example. So you can see like these little boxes. These boxes we are considered as pixels. So the more pixels you have in one images, that will be more qualityful image. The less pixels you will have, it will be kind of like a blurred image. So as an informatician, or maybe as a professional, or maybe as a data analyst, what you will be doing when you will be in a job is that you will get many such images like this, like images with like less quality, less pixels. You will need to use some tools to get the original image out, right? So that is the goal, what the most data analysts or engineers, they do some image processing technique to get the original image from this blurred image, right? So this is what we will try today. So yeah, so this resolutions can be expressed by DPI, and he said pixel per images. So when you are printing the images on paper, photographic paper, then you are considered the quality as dots per inch. And when you are using the digital images in your work, then you will say it as like pixels per inch. How many pixels are there in 1 inches of that image? And as you can see here in this image of the apple, you see many boxes, right? So if each boxes is like colored with a single color, like black, red, green, only 3 colors are used here mostly. So if I assign a number for each of this color, then suppose my white is considered as 0, black is considered as 1, red is considered as 2, green is considered as 3. Then I can consider this entire line of this box as 0, 0, 0, 0, 0, and then 1, 2, 3, right? So if you can represent these whole images with number, then it is very easy to compute and do the processing thing, right? So basically, when you will feed your computer or your device that, okay, this is the image, your computer doesn't have any eye, so it cannot visualize the image the way you do. So how it will visualize? It will get these colors as numbers, and these numbers will be represented by the pixel values. So each of these boxes will be assigned to a number. So I said like 1, 2, 3, so on, but basically these numbers will be different than what I'm saying. Maybe it will get a floating number, 0.001, 0.025, and something like that. Okay, so this row, yeah, Sahiti. Oh, I'm sorry. Sorry. Yeah, now can you see it? Yeah, there's so many notifications over here. Yeah, now you can see it. So each of these boxes that you see, these boxes will be assigned. Thank you, Sahiti, for saying. So these boxes will be assigned with a number when you are feeding a model or you are feeding a toolbox with these images. So yeah, moving on. So yeah, so our objective in image processing is to extract the useful images from an image. Sometimes when you will be dealing with medical images, not everything in your image is needed. For example, I am giving you a scan, a CT scan of a medical image of, okay, what are we getting from chat? Okay, so suppose I'm providing a medical image to you, and I am asking you, maybe you are a data analyst, or you are just like a person who does image processing. I'm asking you that, can you find out the tumor in a brain image? So if you are not someone from medical background, it will be hard for you to get some idea like where is the tumor, right? Like I'm not a medical person, so like I'm not from medical background. It's hard for me to understand like what exactly tumor will be in the brain image. But if you can make a filter, or if you can make a image processor that can identify and segment the tumor thing from the image of a brain out, then other people, whoever is from medical background or non-medical background, they can use that filter or your image processor to do the same thing, right? So as a image processing person or maybe as a data analyst, it will be your job to get into something like that, right? So we need to extract the useful information, because the whole brain image may not be useful, but where the tumor is located, maybe that is useful for the person who will be treating this patient or something like that, right? So, okay, so in the pre-processing steps, there are many types of tasks you can do. First of all, like you can enhance the image quality. Like you do use the app in your phone to do some Photoshop, right? Of your own images. Maybe what do? Maybe you increase the brightness, or you can enhance the contrast, or maybe you use some more colors in that images, right? So all of this thing can be done using advanced MATLAB tools. So that's the something you can do during the pre-processing step. And also maybe you are taking a photo, for example, what I'm seeing from outside, it's like it's snowing, you take a photo of it. You don't want the entire part of it, you only want to see the road. So you segment this road part and take this out of the whole images. So that is called like segmentation. And also identifying and extracting the relevant features. Like maybe in the road, how many cars are there? You segment those cars separately and get those information out. And you actually identify, okay, these are the cars, this is the bus, or this is maybe a bicycle. So you do some classification. So all of these things are included in the image processing part. So moving on. Okay, I have already discussed this maybe. Why is it useful? Yeah, along with this, can anyone say, do you find image processing useful? Some people are from health informatics, some are from bioinformatics, maybe some are from some, yeah.
I think they should also reduce the image size. If you have a really high quality image and do the whole thing, it'll be incredibly large size, which takes up a lot of space and take a long time to process. Segmentation can greatly reduce that.
Yeah, right, exactly. He really said a very good use of image processing. Like when you are dealing with a large data set of images, and each images are like very high size, maybe each image is like 5 or 10 megabyte. You don't want such a big images to get also into the data or image processing part. So you can reduce the size of the images. That is one part we can do using MATLAB. Anything else you think is useful, especially considering medical image?
They are using, like we are doing our analysis, etc. for our analysis, but they're using image processing to actually screen the blood cells to identify potential cancer markers.
Yeah. Yeah, that's the part I think, like something like that I will try to cover in this workshop. Like what did you say? Like they're using cancer cell images.
Well, yeah, they are trying to introduce teach the machine to read the cancer cell. And then when they draw the patient's blood, they get like 15,000 pictures of the blood sample cell. The cell pictures from those blood samples, and then they do the screening to compare the cancer cell with the patient cell. They could have it's a development.
Oh, okay. Yeah, great to hear that. So people who are from biology background, you do a lot of lab tests using like the pathological slides, right? And maybe you document the images of these pathological slides. So those images can be used and you do some image processing techniques on that. And maybe that can be used to do some more research. And as she said, like to compare like the cancer cell images and something like that. And segmentation, yeah, definitely. Yeah.
You do the same for radiographic images.
What graphic images?
Radiographic images.
Oh, yes. Yeah, definitely. Like, as I said, for a brain image, that's a radiographic images, a CT scan or something like that. So you can use that to segment and classify the tumors or what type of tumor is that. So that's basically like segmentation. Yeah. Anything else? Yeah, Saiti.
From the hospital perspective, you could use MRI scan or PET scans
Mhm.
to create like classification models.
Yeah, exactly. So I will not encourage you to do your modeling part or deep learning part using MATLAB, because MATLAB really isn't like meant to do that. But the image processing part you can do in MATLAB. So in order to train a model, maybe you should use Python, like PyTorch. Those kind of framework you should use for model training, but just do the image processing part, use MATLAB. So yeah, so quantitative analysis, as I said, image will have like the quantitative information, so you can extract that from the images and use it. Okay, so what tools do we use for image processing? First of all, my favorite is MATLAB, because MATLAB has a lot of functions, built-in functions, and MATLAB's libraries is very huge compared to Python. Python also has some toolbox, like you can do the image processing using OpenCV, scikit libraries, but MATLAB has more than that. And also you can use TensorFlow, PyTorch. Also Visual Studios like C or C++, these two languages are basically one. So this language you can use for image processing. When I first learned image processing, I used to do that using C, but C is, I will say, a bit complex. Maybe you people, you used C or C++? Because it's not like human language, like Python or MATLAB, it's more like natural language, but C is not. C is very complex. So you need to write a lot of code in that. So that's why I don't like C at all. But the core programmer or who loves programming, they will say, okay, C is very good. I mean, who are doing it, like they're doing the coding for 20 years or more than that, they will say like C is the better one. And also you can do image processing. Right now we have Photoshop, like Adobe Photoshop, or even in our phone, we have many apps. Like I probably use a photo image collage, something I app that I use on my phone. That is also a good thing to do image processing, but it doesn't have any customization. You only need to use how they're presenting their tools to you. You cannot do any customization in that, but in MATLAB you can do. Okay, so as I said, why MATLAB is popular? Because it's very easy to use, and it has a dedicated image processing toolbox that we will be using today. And also it's more, the commands are more like natural language, so that's why it's easy than C or C++. The built-in functions are great, and also there's Simulink. Simulink is something which will let you do all the image processing without doing any code at all. So it has a GUI, graphical user interface, that you can directly use. You don't need to write any code in that. So also MATLAB has a large community where you can post your questions, you start a discussion, and so on. So, okay, so let's start with MATLAB. So I guess if my screen is visible, so I'm just opening a browser. Oh, this is my browser. Okay, so what I'm doing is like, I'm just searching for MATLAB online. You can do the same. So the first result that comes up, MATLAB online, this is the link we will be using, right? Do I need to give you the link, or you can get it from Google? Just search for MATLAB online.
You can also search MATLAB IUPUI.
You will need to log in using your IU credential is in that only. So you go to this link, and then here it will tell you to sign in, like see MATLAB online, and then here there is a, okay, thanks, someone already gave the link. So you sign in here. I sign in using my IU email. You should also be able to do that. So you are about to log in through your organization page. So just using your IU credential, log in here. Okay, once you logged in here, let me see. Yeah, so click on MATLAB, and then here it says open MATLAB online. So it will take you the MATLAB editor page. Give it some time to open the whole thing. MATLAB, why we are doing it from browser? Because it takes a lot of time to download MATLAB and install in your computer. So it is like easy to work from the browser version, but at the same time, this is a bit slower than the MATLAB you will have in your computer. If you have MATLAB in your computer installed, then it is easy. Okay. So as Sahiti said, we are taking a 5 minutes break, and Sahiti will be sharing the folder with you where we have all the MATLAB files. So you should be able to access the files from there. Okay, everyone. So if everyone has this workshop files access, here you see there's like the presentation file and also some .m file. These are the basically MATLAB files. So what I want you is like download this image load, or you can maybe download image load, image classify, or maybe all. First, I want you to download this image_load.m file. So once you have it downloaded, then two way you can run it. One is like, for example, I am downloading this. So then you can open it as a note. So this is the code that we have in this file. So one thing you can do is like either you can copy this thing and paste it in your MATLAB editor, or another way to do is that now that you have this file downloaded, you go to MATLAB. You remember like this window that we have open. Here you have like under your name, like under my name, I have this my account. When you click on this, it takes you to MATLAB Drive. See, MATLAB Drive. So you go to MATLAB Drive, and then here you can upload this file you just downloaded. So upload and then the file. So where is the file now? Image load. So I think I already have this file downloaded. Sorry, uploaded here. Yeah, I already have it. So you can upload this file in MATLAB Drive. Is that okay? Does everyone understand what needs to be done? You download the image_load.m file, and then you download this in your MATLAB Drive. So I guess I have it here somewhere. MATLAB Drive, where is that? Image load. Yeah, this one. So once you have it uploaded in your MATLAB Drive, you go to the MATLAB editor, and then here in the file section, you should be able to find that file. I have many files, so that's why I am scrolling down, but you should only see that file only. Image load. So double click on that, and then this file will be opened. Right? Everyone is there? Okay. The what? Oh, the uploading one. So here you see, you should be able to see your name. So click on that, then click on my account. So okay, I'm showing it again. You go to, oh, why am I exiting? My account. And then here, MATLAB Drive. Click on MATLAB Drive, and then there is a upload option. Yeah, so yeah, so once you have opened this image_load.m, so one thing you should understand is that I always use these three command, CLC, clear on, and close all, because MATLAB has this bug. It has been always like this. I first used MATLAB in 2016. At that time, I also saw that if you don't use these three commands, there will be a lot of windows that will keep popping up and popping up. So you need to clear and close all of them so that it doesn't like disturb you while you are working in MATLAB editor. So CLC, clear all, close all will basically close all the unnecessary files that you have opened up. And also clear all will clear all the commands you will have in command window. So, okay, so MATLAB is, this command window is basically pretty much easy. For example, like I am writing 2 + 3, it shows answer equals to 5, and those all type of commands you will say here, it will give you the answers in this command window. So does everyone see that, or I need to maybe make it full screen? Okay, so here all the results will come up, all the code that you do, and the code you will do is here. So here you can see it's showing that an image, how to load an image. It's showing you need to load an image that says cat_small. So you can use any image here. You can either download an image, like let me do that, just cat image. Just get any cat image. Which one I should take? All are cute cat images. Any recommendation what I should take? Maybe this one. Oh, that's a very big cat. Big cat as in like the size is like the pixel values will be large. I want a small image. Maybe I take only this image, like save this image as cat is small. I want a small sized image. That's why I didn't download the big images. And then how do I bring this out? Okay. And then I go to my MATLAB drive and I upload these images here. Okay. So upload a file. I'm uploading this cat small JPEG. Upload. Okay, so everyone is done with getting an image, cat is small. Any image, like you don't need to get the image that I took. You can use maybe cat image or maybe dog image, any image. So then you need to run this code. Just click on run. Okay. So nothing's there because we don't tell the code that show me the image. So if you want to see the image, you just like uncomment this line image. So what happens now? You run it again. See, lot of numbers coming, right? So what are these numbers? These numbers are like the pixel values from your cat image. So does this number give you any result? Do you understand from anything from this? You don't understand, but the MATLAB is understanding what you are saying. So all these numbers are basically representing that cat image, all those pixel values. This image probably has like thousands of pixel values, so all are coming together. So if you want to visualize or display the original image, so you uncomment these lines. So how do you uncomment like multiple lines together? You just click on Control R or Command R. Oops, why it's not happening? Shift R. Let me try. Oh, no, I think Control Shift R. No, it's reloading. Okay. It was working in my laptop. Why? It's not. What one?
Control Shift R.
Control Shift R worked for you.
It might be different for the app.
Yeah.
For Mac, it's not. Yeah. Okay. Anyway, I will just like manually do it. So this function that IMRead, this one loads your image, like the image that you are saying, cat is small, and imshow, image show. This function is showing the image. So once you run it, this one figure should come up and then it's showing the original image. So what happens when you don't use the CLC clear all close all? What happens is that this figure doesn't go. Rather, it creates another figure. See, the figure 1 is also there, figure 2 is also there. So it will keep popping with new windows, new windows. So you don't want that. So you just write this thing, clear all, close all. Yeah. So you're seeing the original image that you just got from Google and use that as catsmall.jpg. And now I want to see the grayscale image of this. So how do we do that? So what does it mean by grayscale is that you want to see the black and white version, basically not the black and white version. It will also have like the gray versions or gray colors in that. So what it is doing in this code is that it's checking that whether this image, oops. Okay, that's weird. It's giving me like the command. So what it is doing is it is checking the color spaces. If there is like 3 color spaces, like this size, the size of the image, the number of color spaces you have, this will basically represent the size of the image. If a colorful image will have definitely 3 color spaces, the RGB one. So it's basically checking. You are pretty much familiar with the code part, right? Like what's happening here, like this if-else statement. You understand this, most of you, I guess. So what it is doing is that it's seeing if there is like these 3 RGB color spaces. If it is, then it is using this RGB to gray function. This is a built-in MATLAB function that makes the grayscale images of a colorful image. And if there is not 3 color spaces, then it's basically the original image is getting considered as grayscale images. So, and then you can display the grayscale images. So I'm uncommented this. And let's see what happens. So figure 1 is the colored image, the figure 2 is the grayscale image. Okay, then what else we can do here is that Gaussian filter. What is Gaussian filter? Anyone knows? Like what is Gaussian filter? So MATLAB has a built-in function. So people who are from like math background, they will know about Gaussian normalization. So you basically normalize a thing using Gaussian filter. So if your image is like has a lot of sharpness, it basically smoothens it out or makes it more blurred. So it will get a filtered image out. So that you can do. So I'm uncommenting this. So I'm using a filter to smoothens this image out. It's already like a blurred image, but still let's try and see what happens. So original image, grayscale image, and filtered image. See, it's more blurry, right? This is my original image. This is grayscale, and this is the blurred image. Like from the grayscale image, it's getting into a blurred image. So you are smoothing all the sharpness from these images using a Gaussian filter. So IM Gauss filt is the function that you need to use. And then edge detection. What's edge here? So as you can see the original image, this the edge of the cat, right? So the edge you want. Also there is the face and there is like the hairs and there's like nearby the eyes. There is also edge. So all the edges that you have in these images, that's what you want to see. So for that we have a edge function, and also you want to define like what type of edge detector you want. So I'm writing canny. You can use some other edge detector and then you see it. So let's try that. So this is my original image, grayscaled, and see this is the edge detection, like the edge detected from the original image, right? So the more high quality image you put, the more like the better way you can get the edge. So I don't think this one is doing much good. So we can try some other type of edge detector. For example, in the presentation file, I mentioned some names of edge detections. For example, try other edge detectors such as Sobel, Zero Cross, Log edge detector, Previt. There are many types of edge detector. So we can use Sobel and we can see if that is a better one than Canny. So use a Sobel edge detector and run this code. What happens? Is it a better one than Canny? What do you think? I think, yeah, I still get the A's, but it's not like Canny. It's completely a different one. How about we try some other one, maybe Zero Cross or Log. The Log edge detector we can try and run it. Yeah, I think this is a better one than Sobel, right? Okay, so till now, does anyone have any question? What we are doing here? Anything? from here. So you understand everything what we did here, like pretty basic things, right? Yeah.
Like these modules.
You want to install them or just like you want to install MATLAB?
No, I'm saying, because I'm trying, it's saying that the functions don't exist, undefined function there. What are you,
Okay.
a package you have to install, like in Python?
No, nothing. Let me check. What we are doing. Like basically. Oh, you are doing it, MATLAB 2023, right?
Yeah.
It would be that your MATLAB have this function. So, we are using like the most recent one directly from MATLAB website.
Yeah.
So why don't you try that from the online version?
Okay.
Maybe the version that you have doesn't have the right?
The most recent version beyond the.
Yeah, then 2023 should have like this.
Okay.
That's a bit more. Maybe try the online version. Okay, moving on to the next part, what we want is, so yeah, why don't you try another file, which is, okay, why don't we try the image classify one? We don't have much time. How much time do we have, Sahiti? Anyway.
I guess if
Mhm.
you guys have any other kind of conflict, feel free to.
Okay, we can just check one like image classify and the others you guys can be try like in your home. And we can go through just one medical image segmentation part and let's just try with the image classify one. So why don't you guys download the image underscore classify, this file, and then upload it in your MATLAB drive. Do you think you can do that? Yeah, just download this image classify one and then download this and then upload in your MATLAB drive here using upload. And then you open your MATLAB editor and then from the files on the left side of your screen, you should be able to see the image classify.m file. Where is that? Yeah, so double click on that and then you have image classify. Okay, so we want to classify an image using a built-in model. So we are using a pre-trained CNN model, MobileNet version 2. This one is like very strong model that we also use in Python. I mean, some people have used. So as I said, I don't recommend MATLAB to use image classification, but just for the case of learning, we are learning it how to do it in MATLAB. So it's basically same the way we do it in Python. We get a pre-trained model, MobileNet version 2, and then we load an image. So for example, I'm using an image of a chair. You can get like that cat image. So cat, small JPEG. So that same image you can use for the classification. So your image, you are defining what is the input size, and as this is already a pre-trained model, this one is expecting a specific size of your input image. So you are defining that here. And once you have all things ready, you just use this classify function from MATLAB to get the image classification out. So how about we try this and see what comes up? So you remember like cat is small is basically a cat image. Does it give me cat or something else? Let's run it. I hope I'm not getting any error. Okay, so it's saying that the predicted class is tiger cat. What's tiger cat anyway? Is it like, okay, so this is like a type of cat. It's not classifying it as tiger or cat. It's basically classifying it as a specific cat. Like so it got to understand that this is cat, and also it is saying the specific type of the cat, or maybe the breed of the cat, tiger cat. Okay, so pretty much this is pretty much easy because we already have the pre-trained model. If you don't have that, then it will be very difficult. Everyone is here. So what it comes up for you? You tried the what? but it's not shuffle, right? What's that anyway? An animated cat, right? So, okay, so your model didn't perform well. Anything else you got? Cabby cat. Okay, so what was your input image? Cat. Cabby cat. Okay, so correct. Okay. And so I think her model didn't work. So she put a cat image and you got a what? The shuffle. Okay. So that's wrong. Anything else you got? Maybe you can try to give your image and then see what it comes up. I tried and then it was showing, I don't know, I mean, it was showing like as something, a scenery type of thing. Like why it would like classify me as a scenery type of thing. Maybe it was showing some nature or something like that. Okay. So sometimes these models work, sometimes don't. Okay, let's, I will get into some other thing. So this segmentation, filters, abnormality detection, that one is pretty easy. You can try by yourself. I can try the segmentation one for you. So how about we try the segmentation one? So what is that segmentation? Yeah, so segmentation.m. So what it does is that, so you can see like the first work that you need to is like you need to see what exactly the image you are giving as input. So once you have the image ready, you either can do reshape or you cannot do the reshape. That's completely your wish. Without even doing like reshape thing, you can do it. So then you do some k-means clustering. So this is not exactly like needed. It's just a extra step you are doing. And then for each of the color space, you make segmentation. So for the RGB one, you are getting one space. For the RGB green one, you are getting another space. RGB blue one, you are getting another space. So each of these color spaces will give you one segmentation, so in total 3 segmentations. And then you will get a color mask for each segments. And then, as you know, when you have 3 color spaces from one image, separately of these 3 color spaces, you will not be able to visualize the image completely. When we stack all the layers from these color spaces together, then only we can visualize the image. So I will just like run this code so that you get the example. So what's happening? Okay, so how about we, yeah. So this is my original image of some papers, right? Red, green, and yellow paper. So the segmented one. So for this image, you are getting 3 segmented part. So one part is probably showing only the red color space, another one is showing the green color space, and another one is showing the blue color space. So these 3 are here. So you are highly, like it's highly unlikely you will be able to understand what these images are showing. And that's why you are putting individual color mask in that. So then you are getting this, but still you are unable to understand what these things are, right? So then you are stacking up all the layers together and you are getting an overlaid image. From here, you can see that okay, these images are like maybe papers. So you already know the original image. Suppose you don't know the original image. I'm only giving you like the segmented image. So how do you get to know like what exactly here in the segmented image? So you do some processing, you use the color mask, you overlay all the layers, and then you get image. And from here you get to understand, okay, these are papers. Okay, so then you get the enhanced contrasted image, and then you try to see the difference. So this is your original image, this is your enhanced contrasted image, that one you just reconstructed. So when the difference is basically black, that means there's basically no difference in the original image and the enhanced contrasted image, right? So what you reconstructed from the segmented image is basically the same of the original image, right? So this is what is expected from you when you will be doing some image processing. We will give you some image, some bad colored, or maybe some zoomed out, or maybe highly blurred image, and we will ask you to do some image processing and get the original image out, right? So this is expected from you. Okay. Okay, now what we are doing is so then let's go back to the files. So I think the filters one, abnormality detection, this one you can do when you are home, you can do at your own pace. Let's try this medical image segmentation. This file has some good tutorials, like I should be able to see it from here. So file exchange and then medical image segmentation. You can like directly download this file and then upload it in your MATLAB drive and you will be able to see that. So here they have this cell segmentation part. So if I open that, so here we have some good things like, I think this one is the image coming from a pathology slide where some cell, like these are the nucleus and these are like the complete cells. So this is like a very, very, very zoomed in image that we are trying to pre-process. So these are the all things that we already did. We know how to import and visualize image, how to display a image. Okay, why there is a brain image here? Okay, maybe we should change this to cell. Maybe cells.jpg and then run it. So here is another function that we can use. What is that? Cells.jpg doesn't exist. Why it's just saying like that? Here I can see cells.jpg. Yeah, it could be. Thanks, IT. Let me try. Required files/cells. No, it's some other issue that we are getting. Oh, we need to run this cell first so that the path is going like required files. Cells. Okay. Cells.jpg not exist. Okay. I got and I understood what happened is that so this file exchange, we should have this file.
When I type in medical image segmentation,
then it works. So I need to write it like file exchange slash.
Yeah, or you could just put medical image segmentation. Oh, yeah.
Now it should work. Yeah, so I got the image and then cells, display the image. So there's one thing is that when you use this IMF info, all the information that we have for this image, the width, height, and everything comes up. So what I wanted to show you is that to check the pixel values from this. So how we can do it is there is an image viewer thing. image viewer. Maybe try image viewer. So if you search for image viewer, does everyone see image viewer? So here in like search, if you search for image viewer, you get this app. So MATLAB has all those built-in apps already there. So you click on like, there's some image editor as well. So you are just clicking on image viewer. So here I'm importing this sales image or any image from workspace. Okay. How about I import from file? Maybe this cat is small. So you are seeing this cat image that we downloaded previously, and you are zoomed into this, more zoom. Now you can see the pixels, right? Get more zoomed, zoom, and then now you see the RGB value, right? So basically, these are the information you need to feed your computer, right? So we cannot see it, but your computer can. So like the red color space value is 2014, green is 145. So for each of these pixels is different. See, all are these like different colors. I got this like internet meme where there was it was a very like a I found it very funny meme that it showed that female are more likely to know about the shades of colors, for example, like the makeup colors or maybe like the lipstick colors, but male don't understand. Is it like that? Males, you don't understand colors? I guess you know. Even I don't understand like what's the difference between this color and this color. Visually, I don't understand what's the difference between these shades of brown color or whatever it is. So when you are doing the image processing, it is very important whether you are a male or female. You need to understand the differences of this color. Unless you don't know it, it's like it's not going to work. So see, the more the difference is, the more your image will be, like of high quality. Let us try for another image, maybe from file. Which one we should do? Maybe chair. What is that? Okay, so zoomed in. See, even if all of this looks white, these are not. Even if like this one looks white, it is not exactly white. So there's a slight difference of this green and blue color space, right? So with these differences comes up different shades of colors. So yeah, so these values are needed. So that thing you can try using this image viewer. So what we were doing with the past task is that we are using this cell image. We are showing it, and then this is the pixel values it is showing. Okay, so binary version of an image. So this is basically that you can do is when you are converting a binary transformation of your image, all of these color space values will be considered either 0 or 1. So this is not like a grayscale image. This is completely a black and white image. So the one we said as black and white, that is actually grayscale image. This one is actually a black and white image. So these RGB values will be either 1 or 0. And then moving down, we have already used this image viewer app. So there's a lot of this RGB to gray. This one we already have used, that how to convert a colorful image to RGB1. And so, okay, so this image that you can see, I don't know if I can like zoom in out. So these 3 images that you are seeing, these ones are basically like 3 color spaces. The first one is like the red color space. This one is green. This one doesn't. This one is blue. Doesn't make sense, right? At first, when I learned this, I thought like, okay, the red color space will be probably only full of red color, but it's not like that. It's called as red, green, blue for a different reason. So when you stack up all these three images together from 3 color spaces, then you will get this colorful, the original image out. So this is the thing you can try out. So another thing that you can try is this other example 2 of cell segmentation. So this one also you probably use a pathology slide. Okay, so this one is a zoomed image of a pathology slide. So what they're doing is that I want to segment the specific area. So why it's not opening up? Maybe I can open it up like this. This is not opening up. Open. Okay. Image viewer maybe. Okay, so maybe you want to create a boundary of these images because you don't need the other part. You want to create a boundary of these images. So I'm not running this code again because these are pretty much easy. You can try yourself. Cell 2. Okay, again, these brain images are coming. File exchange. Run. Import the cell 2 image, run it. Okay, so this is the original image. I want to create a boundary of this. So they are showing a different type of filters that you can use. Range field, STD field, entropy field, and everything. All of this entropy is showing like how you can either add noises in that or you can like take the noises out. Then you're rescaling the images, rescaling the intensity value 0 and 1, use rescale function. This is already given in MATLAB. So this is maybe like a high intensity image. Then you are binarizing it. So giving only like 0 and 1. So this is not a grayscale image. This is a binary image. All the RGB values or pixel values are basically 0 and 1. So now you can see the boundary pretty much clearly, but what about you want to draw a boundary in it? So morphological operation, for now we can just skip that. So morphological operation is basically the simple thing that we did in edge detector. So in edge detector, what you did is like you tried to find out the, so for example, if we run like the image load file, is it running? Where is our files? It's not there. Okay, so when you run the image load file, you see the edge all around the cats, right? So what this morphological detection does is that, where is our morphological? Yeah, the morphological operation does is that near the edges, it gives some blurring thing. For example, you don't need to blur the entire image. You only need to blur where the edges are. So you first find out the edge and then you do the blurring or maybe smoothing or maybe you make it more sharp. So there is this morphological operations that you can IM fill, then this functions that you can use. And so they are doing it on the binary image. Then you can remove the small areas. For example, I don't want these small white areas. So then you can use the BW prop filter function. So as I said, there's huge number of functions in MATLAB which are already built in. So you can just search around and use the appropriate one that you need. And then see all those small areas are removed. And then you want to create the boundary. So what you do, you use this BW boundaries function. So everything is pretty much like already added in MATLAB. So you don't need to write the code all by yourself. So from the original image, you add the boundaries and you get it. So this thing we did for a pathology slide image. you can do it for maybe try yourself with a brain image, get a brain image as your original image with a tumor one. So it probably will have a tumor. Try to segment the tumor part out from the original image and then add a boundary around it. So that's the task you can do. Maybe you can get a model out from that. So entire thing you can like automate it, save it as a .m file. You can add, if you have your own GitHub repository, you can add it there. Maybe add that in your portfolio that, okay, I have created a MATLAB function that identify a tumor in a brain image and then creates a boundary of around that. So this is kind of, you can do as a maybe a course project or something like that using MATLAB. Any other idea you think you can do using this? Anyone that you think like whatever you tried today or learned today, you can use to do some projects? Yeah.
Like there's a pump of cell types
Mm-hmm.
that's distinct from the others.
Distinct from others.
Yeah,
Okay.
it's like you can tell.
Okay. Are you from like a biology background? Okay. So what type of cells are like distinct from other cells?
Like here you have like an image, right? So you have the type of like a single cell spatial image, right? So you have them all annotated.
Mm-hmm.
You have it draw sort of around the distinct. Usually they're distinct colors is what you can annotate them as. You have like,
Okay. Okay. Yeah, that's another idea you can try to implement. So in my undergrad days, what we did is like we had a couple of images of hand signs, you know. So blind people, not blind people, deaf people or who can speak, they use some sign language. Like for example, this is C, right? This is probably V. So this type of sign language they use because they cannot speak. So this type of signs, hand signs, basically, we have used the images of these. So we took a photo of our hand writing this, and we used to give MATLAB. They used to process this and then use the classification and saying, okay, this is C or this is A, this is P. So that thing I had tried in my undergrad using MATLAB. So you can try to see if you can do something like that. Yeah.
Histology identification. So where tissue being sliced,
Mm-hmm.
to see slides where medical students normally use microscope
Mm-hmm.
to visualize cell type, or like the metaspaces on cells, where clear boundaries are set for those cancer tissue versus the normal tissue adjacent to it.
Okay.
Yeah, have you tried to use?
I haven't tried like specifically on medical images. I haven't. On medical images, I have like currently I'm working all of this medical image analysis using Python. That is more problematic, but all the time you cannot like use MATLAB. So MATLAB, all of these functions that we use today, like RGB2 or like Gaussian filters, those are available in Python, like the basic ones. Like maybe the advanced one, for example, this BW black and white boundaries, or maybe just BW boundaries. This one probably will not find in MATLAB in Python, but the basic ones you will find in Python, and you can do the image processing using that. So I have been doing that in Python. I mean, for the advanced things, I don't do. It's a simple thing. And the advanced things I don't do in Python. The basic ones you can do in Python. Try that. Yeah. Any other question you guys have till now? What we have covered? I mean, we are over time, I know, so I didn't show the other parts. If you have any questions from like the filters, there's in this filters.m we show some along with the Gaussian filter, we have some other filters here. So we show the application of that. And abnormality detection, this one is basically takes a medical image, for example, a brain image, and try to see if there is anything abnormal, maybe a tumor or some, I don't know. I mean, biology people will be able to say this clearly, like what do we find abnormal in a brain image? Tumor, right? Tumor, or maybe like blood clot, something like that. So those things you can find using this abnormality detection MATLAB file. Okay, what else? Any other question from here? Do you think you can use MATLAB in your area when you are doing some coursework or you are doing some research? You think so? You can do, yeah.
Yeah, but question, so with the cell segmentation part 2,
Mm-hmm.
it seems only the cell 2 image was working in that one. He tried to use brain scan or cells.
Mm-hmm.
It came to the
So it's not like working for your brain, this brain scan image, right?
Yeah.
I guess that is because,
thing was that it was expecting 2 dimensions, there's only 1 dimension.
oh, okay. I guess that is because from what I am understanding is that this scan 3 image is already a black and white image. Could be, I mean, I'm not sure. These all are from Google. So I didn't get them from a original data set. These all are from Google. So does it work for cells?
No, it doesn't either. It only works for cell 2.
Oh, because probably, let me check why it doesn't work. So these are already like built in MathWorks. So if you go to MathWorks website, MathWorks website. So I got them like directly from MathWorks. These are all MathWorks parts. So the reason why it's not coming for cells is probably because it's showing you a size issue, right? The shape or size issue that this is like a 3D image and this is not.
It's saying there is expected input number to be 1, black and white to be 2-dimensional.
Can you again repeat that?
I'm saying it's in the 3B, move small holes.
Okay. So I understand now. So in this image, you are getting the error when you are using cells or scan 3 is basically here, right?
Yeah.
Like BW prof field. Probably it couldn't identify the holes in the cells or scan 3 images. I guess that's so because here pretty much there's a big area and these are the small areas. So that's why it's filling up the small area. Your cells or scan image is not like that. Maybe try to do it with a similar image like that.
Okay.
Yeah, and for the scan 3 image, I think this is a bit problematic image because this is a medical scan, which is already probably a black and white image. Maybe that's why it will not work for this too. So when you are dealing with a medical image, you will not be given a direct JPG or PNG image. Those will be converted to DICOM image. So you will need to use, you will need to learn how to do the image processing using DICOM, but it's pretty much same. So this function, IMRead, can even like read DICOM. So you can use IMRead and then do all the things. Okay, so I think, yeah, we are pretty much done what we needed to cover. So I would ask you go through these 2 tutorials. One is like cell segmentation from the colorful image, and another is like segmenting, creating boundary, and then filling up the holes. So that part is also you can try. And also try to get some images from Google using similar images and then try if that also works. And there's different functions along with IMField or other IMField or this BMW prof field. Maybe use other filters as well if you think those are appropriate for your image. So that's the thing we need to learn, like what type of functions is more appropriate for my type of images. That's what you need to learn when you are doing image processing. Okay. Anything else, everyone, or else we would just end the session.
I assume MATLAB has like a documentation website where they list
Yeah.
all the functions.
Yeah. So I guess all of the function, if you just search here, BW prop field. So just click on that. It will take you the documentation site on MathWorks. So here is like all the documentation, what it does, how it does, everything is there for all the functions. Like if you just write IMRead, which is the basic function, IMRead, and it takes you to the documentation. Yeah. That's it.